Hello student, welcome back to lecture series on linear algebra. So guys, in our today's video I'm gonna explain to you all some of the example based on the echelon form or canonical form of the matrix. So for using this one echelon or canonical form, we used to find out the rank of matrix. Okay, so in my previous lecture guys, I have explained to you all how echelon form or canonical form work. So here in our today's example guys, I'm gonna explain to you all a row echelon or canonical form and how can we find the rank of matrix using row echelon or canonical form. Okay, so let's do it. Okay, yesterday I explained this part. In my today's video I'm gonna explain to you all with some of the example. Okay, yes, so we have example entries are here 2 3 -1 -1 1 -1 -2 -4 3 1 3 -2 6 3 0 -7. Okay, this one is a 4 by 4 matrix. So without further ado, let's get dive into our today's lecture. We're gonna see how to find the rank of matrix by row echelon form or canonical form. You must remember the only procedure for finding it. So the part of solution, let me explain guys. Okay, so what we want the first element as a 1. Okay, first our task is for finding the rank of matrix by using row echelon form. First we convert this element is to the 1. Okay, then this 0 and this one is 0. Okay, later on we try get this one is 1, then 0 0 0. Okay, so if it is not 0 not there, not a big deal. Okay, so we try get the lower part. Okay, lower part of the matrix 0. This is 1, then remaining 3 0. This is 1, remaining 0, and try we convert remaining these are all to 0. Okay, so that we can get easily one of the row like this form as a 0. Okay, one of the row as a 0. We want the row, one of the row 0 for finding the rank. Okay, and if it is not coming 0, then it is okay, so we will write the full rank matrix. Okay, yes, so now see that in this case we want the here as a 1. Okay, so we want the operation on r1. Okay, what is the operation on r1? We want the operation on r1. What we can do r1 so that we'll get it 1 here. So better what you can do, you can replace r1 to. Okay, so I have to replace r1 and I want the operation on r1. What is the operation on r1? R1 and r2 should be interchange. Okay, so operation on you can go directly like interchanging of the operation. Okay, like r1 to. Okay, r1 to, that means operation r1 to means r1 and r2 can be interchange. Okay, yes, let's interchange. We have done one of the operations. So what we have done here, so we replace r1 and r2. You can interchange r1 to. Okay, row to the first row to the second row and second row to the first row. Okay, the value of matrix it won't change. Okay, yes, so what we want next, our first target is to make this one 1. Okay, so we got this one as 1, so remaining 3 element we want 0. So we want 2 as a 0, 3 as a 0 and 6 as a 0. Okay, so define the operation accordingly. So what operation we can do, so if we use r2 minus 2 r1. Okay, r2 minus 2 times r1. Okay, so operation on r2 minus 2 times r1. Okay, this one is the first operation. So if we go for more operation, okay, so we can go for the r3 also. Okay, r3 we want the operation on r3. Okay, so what can be the operation on r3 possible? r3 minus 3 times r1. Okay, r3 minus 3 times r1. Okay, you can see that 3 minus 3 it will be 0. Okay, and operation on r4, add all the 4 of 3 operation together. Okay, we want the operation on r4. So what can be possible operation on r4? So we write r4 minus 6 times r1. So we want 6 minus 6 0. So r4 minus 6 times r1. Okay, see that I'm taking 3 of these operations together. Okay, so make sure that r2, r3 and r4, these 3 not rows are not involved. Okay, so that we can easily get the all calculation together. Okay, so calculation it is only on second row, third row and fourth row. Okay, so we have the calculation only on the 3 rows. So all remain, r1 remain as it is. Okay, so 1 minus 1. Okay, r1 it will remain as it is, 1 minus 1 minus 2 minus 4. Okay, so we want the operation on R2. What the operation? R2 minus 2 times R1. Okay, R2 minus 2 times R1. 2 minus 2, it goes to 0. Okay, again R2 3 minus 2 times R1 minus 2. 3 minus minus 2, it will be the 5. Okay, 0 5. Again 3, we want 2 minus 1 minus minus 2. Okay, minus 1 plus 2, which is the minus 1. See that what we have, minus 1 minus, we are multiplying 2 to it. Okay, so minus 1 minus of minus 2, so minus plus 4, so it will be the 3 only. Okay, so this one remain 3. Again R2 minus 1 minus 2 times R1. Okay, so minus minus, it will be the plus. Okay, 8 minus 1, which is a 7. Okay, yes. Okay, this one is operation on R2, so I got the second element 0. So similarly I want third element 0, so we are going to operate with the first R3 minus 3 R1. Okay, so multiply 3 and subtract from here. So 3 minus 3, it will be 0. 1 minus minus 3, it will be the 4. Okay, and after this we are operating R3 row. Okay, 3 minus minus 6. Okay, 3 minus minus 6, that means 3 plus 6, which is a 9. Again minus 2 minus minus 8. Okay, minus 2 plus 8. Okay, minus 2 plus 8 means so see that minus 2 minus 2 4 8 plus 8. Okay, minus 2 plus 8. Option guys, try write separate operation so that you will get the easy calculations. Okay, this one is R3 row minus 3 times R1 row. Okay, 3 minus 3 is a 0, 1 minus minus 3 is a 4, 3 minus minus 6 is a 9, minus 2 minus minus 12. Okay, so minus minus 12 is plus 12. Okay, 12 minus 2 is a 10. Okay, this one. So similarly we want the operation on R4, so it will give us 0 9 12 17. Okay, 0, that means 6 minus 6 0 0. Then after this 9 12 and 17. Okay, so you can see that R4 minus 6 times R1. Okay, so 6 minus 6 0. Okay, minus 6 here, 3 minus minus 6 is a 9. Okay, so 0 minus minus 12. Okay, so it is plus 12. And again after that do it for the third one also. Okay, so we got 3 elements are 0 here. Okay, yes. So I want, okay, I want below a to 2. Okay, next target is here, we want this one as 1. Okay, instead of 5 we want 1, so 1, we got all 0, so we want this one and then we go for the 0, so we want this one as 1. Okay, so how can we make 1? So if you are taking operation, so we want the operation on R2. Okay, so what is operation on R2? We want the operation on R2 is R2 minus R3. Okay, operation on R2, it goes R2 minus R3. Okay, so here we have operation on only R2, so R1 R3 R4 it will remain same. Okay, what is the operation on R2? R2 minus R3. Okay, 0 minus 0 0, 5 minus 4 is 1, 3 minus 9 is a minus 6, and 7 minus 10 is a minus 3. Okay, I hope you all have understood. So we got the 1 over here. Okay, so our now next task is to make this 0 and this 0. We are not going for this one as. Okay, so we are looking for the leading non-zero entry. Okay, so instead of 4 we want 0 and instead of 9 we want 0. Okay, so what are the two operations we can do here? So next operation here, we want this one 0 and this one 0. So if you want this one 0, you can operate this one. You cannot operate with the first row. So if you are going to operate with the first row, that these elements are going to change. We do not supposed to change this 0 and this one. Okay, and this one also. So our next target is that to make that 4 0 and 9 0. So what if we multiply 4 to the second row? Okay, and which subtracted from the R3. Okay, so we will get the R3 as a here 0. Okay, and similarly if you multiply 9 here and subtracted from here, it will be 0. Okay, so operation is on only R3 R4, so R1 and R2 it remain as it is. So let's do the operation R1 R2 as it is. Now we have to change R3 and R4 only. Okay, so what we have, R3 minus 4 R2, R3 minus 4 times R2, so it will 0 only. 4 minus 4, it will be 0. Okay, so 9 minus minus 6 4s are 24. Okay, 9 minus 9 plus 24. Okay, which is a 33. which is 33 and 22 here. Okay, yes, this one is row R3, we replaced. Now we want the R4 row, R4 minus 9 R2. Okay, so that we can get the 0 here. Okay, so this one remains 0 only. R4, 9 minus 9 times R2, which is a 0. Okay, 12 minus 9 6. Okay, so after that subtraction you will get the 66 here. Okay, and here 44. Okay, as it seems like these elements are quite bigger, so you can divide by 11. 11 3s are 33, 11 2s are 22. Okay, 11 6 are 66, 11 4s are 44. Okay, so that you will get the possible smaller elements. Okay, or what you can do, you multiply R33 to 2 and subtract it from here, so you will get the entire one of the row which is at the bottom will be 0. Okay, so I want 66 as a 0 and 44 as a 0. So what you do, so you multiply 2 to the R3. Okay, so we want the operation on R4 now. Okay, let's do the operation on R4. What operation R4 needed? R4 minus 2 times R3. So see that what it can be possible. 2 times R3 means R3 33 to the 66, 22 to the 44. So this can give us entire row 0. Okay, so let me write this one. Okay, so operation on only R4. Okay, R1 R2 it will remain same. 1 minus 1 minus 2 minus 4. Okay, 0 1 minus 6 minus 3. Okay, so R1 R2 remain as it is. Okay, 0 0 33 and 22. Okay, so this one also remains same, only operation on R4. Okay, so what is the operation R4? 66 minus 2 times R3. Okay, 66 minus 66. Okay, that one goes to 0. 44 minus 44, that one goes to 0. Okay, so if you want, you can divide by 11 here, so you will get the 3 here and here 2 here. Okay, but we want the leading element as 1 here, so what you do, divide by 33. Okay, so we want operation on R3. What is the operation? 1 by 33 into R3. Okay, okay, so what we will get, operation on only R3, so remaining keep as it is. 1 minus 1. Okay, minus 2 minus 4. Okay, this is the matrix. 0 1 minus 6 minus 3. Okay, entire last row it will remain 0. Okay, we are dividing by 33, so 0 by 33, 0 by 33, 0. 33 by 33 it will be 1, and 22 by 33. Okay, so we write 2 by 3. Okay, so see that this one is our required row echelon form. See that, guys, how easy it is. Okay, to find out the row echelon form by using a row transformation. Okay, so here you can see leading elements like pivot elements, they are non-zero and equal to 1. One of the row, it is a 0 here, and which placed at only the bottom. Okay, so here you can say this one is the row echelon form of the given matrix. Okay, yes, so this one is our row first, this one is a row second, this one is a third, and this one is a fourth. Okay, so number of a non-zero row in our matrix, how many non-zero row? This one is row 1 is non-zero, row 2 is a non-zero, row 3 is a non-zero. Okay, so number of a non-zero row is a 3. That means the rank of a matrix is a is a 3. Okay, rank of matrix A, consider this matrix as A. Okay, consider this matrix as A here. Okay, so I got the rank of matrix is a 3, and entire column, entire row is a 0. So that means the nullity of a matrix is a 1. Okay, so we got the rank of matrix as a 3 by using row echelon or canonical form of a matrix. Okay, I hope, guys, you all have understood how to solve a given matrix by using row echelon or canonical form of matrix. For your understanding, you can refer my entire solution over here. Okay, it begins from here, and this one is entire solution. Okay, so always remember, guys, operation need not to be the same. I don't know what you are thinking other operation, you can use anything, but just follow the procedure. if that elements are going to change doesn't matter in a matrix. Okay, we are looking for the non-zero entire row. Okay, so that we can define the rank of matrix. Okay, yes. So that is here for today's lecture, guys. I hope you all have understood for everything here into my today's lecture. I'm gonna give some of the example for your homework. Give me the answer of that example. So guys, here I have added some of the examples for your homework. Okay, so find out the rank of matrix by echelon or canonical form. Two matrix I have given here. Okay, so you can use these two matrix and tell me the answer in my comment section. Okay, I hope you all have understood here my entire lecture today, and give me the solution of these examples in my comment section. This one is compulsory for everyone. I want the answer here in my comment section. Okay, so thank you everyone, thank you for my today's lecture. Okay, similar to kind of lecture I will upload again and again. So I hope you will have understood everything here into my today's session. Okay, so thank you everyone, thank you for my today's lecture.